Welcome to ClickMyProject.com. Our project title is an efficient spam detection technique for IoT device using machine learning techniques. Now we are going to see the project abstract. So with the rapid development of IoT technology, smart home system getting more and more popular in our daily life. So here we are going to expose the user to secure the home system as a smart from the risk. To enhance the functionality and the security, here we are going to apply the machine learning algorithm to play an important role in smart home ecosystem, that is for example anomaly detection. So it increase the volume. The IoT device produce a large amount of data with a number of different modalities having various data quantity defined its speed in terms of time and position dependency. In our proposed overall smart home system model, we investigate the application of learning algorithms in smart home IoT system security. To achieve this objective, spam detection in IoT using machine learning framework is proposed. The dataset is split into category train and testing the research. Additionally, the proposed method performance is good as compared with the existing method. Now we are going to see the flow of the project. So here we are selecting the smart home IoT dataset. So here we are going to load the data into the process, and then we are going to pre-process it. In pre-processing we are going to check the missing and null values are there. So and then we are going to select the features and visualize the data. So then we have to splitting the data into train and test. After that we are going to classify using the deep learning algorithm, and then anomaly detection. And there are three steps in the anomaly detection. One is exponential smoothing. So another one is autoregressive integrated moving average model, that is ARIMO model, and time series prediction with recurrent neural network, this LSTM RNN layer. So LSTM layer in RNN neural network. So then the final result will be the loss, that is mean square error. So now we are going to see the running procedure of the project. So here there will be the runtime now. So here you have to click the run all the cells are running. So this is Google Colab. So because of big data, large amount of data is there, so we are using a Google Colab for creating the process. So here this is actually pre-processing in our data set. So it check null values, and then if any null values are there or not. So then here it check the feature attributes and the data types of the features. So then here once again it check after the feature selected. From the feature selection they check whether the null value is there or not. So then this is the memory usage. So then the shape of data set it takes. So and then the progress percentage and predicted percentage and expected percentage and the test MSE of the data. So these are all the visualization of the data set. So this is a moving average window size. Here it shows the green color shows the rolling mean trend, and the actual value is in blue color. So here the moving average window size is 12. So based on that rolling mean trend and actual value is the green color is rolling mean trend and actual value is in blue color. So here the moving window size with the 24. So the rolling mean trend green color is this, and blue color actual value, and the red line here is the upper bound and lower bound of the data. So then here we are see the exponential smoothing. So in the exponential smoothing it shows alpha 03 as dark blue color, so and sky blue color is actual, and alpha 0.05 is in yellow color, predicted data is in green color, original data is in dark blue color. So this is actually a value how it comes. So the ARIMO model, it predicts a progress of 99%, predicted of 95, and expected is 1.3. So and the test MSE error value is 0.076. So error value is low. So this is actually the graph of ARIMO model. So then the time series split is here. So the LSTM works on it. So it will shows the 0.7 something the loss. So this is energy usage prediction. So original usage is in blue color and the predicted usage is in red color. After that we are going to improve the session of the time prediction. So here we are getting a very low loss value 0.3, so the energy prediction. So in this there will be the original usages in blue color and predicted usage in red color. So this is overall process. So thank you for watching this video.